earthquakes, this the point where the energy is released is focus. Whenever it is deeper, we call deep focused earthquakes. If it is near, we call shallow focused earthquakes. Okay, deep focused has less impact as it is far from the surface. Shallow focus has more impact as it is closer to the surface. Deep focus is associated with convergent boundaries. Shallow is mostly associated with divergent boundaries. The point where it first comes to the surface is epicenter. Now, there will be waves from focus to epicenter. Waves are present from focus to epicenter. Words are important. These are called as body waves. From epicenter outwards is known as surface waves. From epicenter outwards is called as what? Surface waves. You see, from focus to epicenter is called body waves. From epicenter outwards is called surface waves. Okay, shall I move? Whose impact is more? Surface waves are more impact, and the impact of surface waves reduces outwards. Fine. Next. Now, body waves, if we take, they are divided into two. Body waves are divided into two. It is P waves and S waves. P waves are also called as primary waves, and they are called as longitudinal waves. P waves are called as primary waves or longitudinal waves. Yes, there will be compression, rarefaction, compression, rarefaction, compression, rarefaction. So, what are the two words here? compression and rarefaction. These two are present. And we also say if particle is moving like this, particle vibrate parallel to wave direction. Particle vibrate parallel to wave direction. Next. They are similar to sound waves. This point is very important. Particle vibrate parallel to wave direction. P waves can travel in solids, liquids. And at last, density is more, speed is more. Density is more, speed is more. All these are with respect to P waves. S waves, they are known as secondary transverse waves. They move in the form of crests and troughs. Particles vibrate, very important, perpendicular to wave direction. They are similar to ripples in water. Travel only in solids. Again, density is more, speed is more. Common property of P and S wave is if density is more, speed is more. Both travel in solids, but both S do not travel in liquids. Next, if we take surface waves, we have two types. Rayleigh waves, where particle movement is elliptical. It is R waves. Love waves, zigzag. It is more destructive. These are surface waves. Now, shall I move? P waves Which waves are we talking? P waves. Okay. S wave shadow zone is more compared to P waves. What is the reason? S waves do not travel through liquids. Okay. Just 2 lines below this. Shadow zones have curved path, curved, curved path, indicating that density is not uniform. That density is not uniform inside the earth. Not uniform inside the earth. Next, P wave shadow zone is less compared to S waves, because S do not travel in liquids. Okay. Shadow zone is because of refraction. So what is happening? Bending occurs. If bending doesn't occur, it will go straight. Because of the bending, shadow zone comes. That is refraction. Okay, that is responsible. Now, yes, this interior of the earth. Interior of the earth. Direct evidences. Indirect evidences. Direct evidences are mining, volcanoes. Indirect evidences are meteor burning, yes, gravitational force. Can we say gravitational force is maximum near poles and minimum near equator? It is also due to geomagnetic field. Can we say geomagnetic field help us in understanding that, like, inside there is a liquid layer? Okay. At last, it is also due to what? Seismic waves. Okay. Direct, indirect evidence. Now, zero to 35, 0 to 5. Continent, ocean. Hundred. What will you have? Upper solid mantle. These two together is called as lithosphere. Till 600 kilometers, it is called asthenosphere. Asthenosphere is semi-solid layer. Asthenosphere. Till 2900 kilometer, it is lower solid mantle. This particular part is called pyrosphere or mesosphere. Okay. Till 5100 outer core, inner core. Barysphere. In between crust and mantle, there is moho discontinuity. Mantle and core, there is Gutenberg discontinuity. Mantle and core, we have Gutenberg discontinuity. Outer core and inner core, Lehman discontinuity. Crust and upper mantle and lower mantle, Repeti discontinuity. upper crust and lower crust, Conrad discontinuity. You have to remember these. Done? Shall I move? Next. Rocks. Primary, parent, or igneous rock. Formed from fire or lava, so it is volcanic rock. Fossils are absent. Layers are absent. You will not have stratification. It is formed due to process, heating, melting, crystallization. Okay, there will be melting and crystallization. 3. Shall I move? Next. Igneous rock is divided on the basis of where it is formed. It can be intrusive igneous rock. Example is granite. Very, very important. Granite is an example of intrusive. As it is intrusive, cooling takes time. Cooling takes time. So we normally observe coarse grains. Lumps will be formed. Coarse grains. Now, this intrusive igneous rock is divided based on the shape. If it is present deep inside, what do you call it as? Batholith. You recollect batholith is what? Deep inside. Deep inside is also called plutonic rocks. Okay, plutonic is also deep inside. Sills and sheets are horizontal. Sills and sheets are horizontal. Dike is vertical. Dike is vertical. Laccolith, which shape? Mushroom shape. Lopolith, saucer shape. Wavy shape. Extrusive igneous rock. Fine grain. Example is basalt. It is divided into acidic rocks, basic rocks, ultra basic rocks. Acidic, basic, ultra basic, based on silica content.